Hi, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to walk you through how to use SPSS to perform a paired or dependent samples t-test. So here's how you do it. I opened up a data set, and for a paired t-test, really there's all you really need is two variables, at least two variables for each case in your sample. But it really makes sense to do a paired t-test when you've got either two matched samples and you want to compare the mean on a single variable, or you've got some longitudinal data, so like before and after data or time one, time two data, and you want to compare a single sample on the two measures of the same thing at different times. So that's what I'm going to do in this one. These are high school students that I collected data from, and I collected data in the fall and the spring semesters of the same year. And each semester, the students received a final grade in their math class. And so I'm going to compare their math grade, the students' math grades at the end of the first semester with their math grades at the end of the second semester. And here's how you do it. You go up here to the Analyze menu of SPSS, and you go to Compare Means, Compare Means, and then a Paired Samples t-test. Then it's going to ask you to pick the variables from your list of variables over here and to create pairs. So I've done Wave 3 math and Wave 4 math. That is first semester math grade compared to second semester math grade. And you can see SPSS gives me room to put in another pair of variables, so I can run several paired t-tests at the same time if I want. But I'm just going to do one paired t-test. And then if you click on options, this gives you a place for deciding what to do about missing data and deciding what level of confidence interval you want. So I'll just leave that as is, and then I'll hit OK. And here is what we get. First, it presents the two means and sample sizes. You can see the sample sizes are the same because it's comparing the same group of students from the time one and time two. So that should be the same. Standard deviations at each time and the standard errors of the mean. And just by looking at these two means, we can see that the Wave 3 math grade, which was in the fall, is 6.994. This is on a 12-point scale, so an A is 12, an A minus is 11, a B plus is 10, and so on. So 6.99, excuse me, that's about a C plus or so. And in the fall, the average math grade was 6.99 for these students, and in the spring semester, that dropped to 6.4369. So we can see that there's a decline in their math grade from the fall semester to the spring semester, and the question is whether that is a statistically significant difference. When you run a paired t-test, you're sort of looking at the relationship between two variables within a sample, and that's what a correlation does. So it gives you the correlation. We can see we've got a correlation of 0.823 in the sample, which is a very strong positive correlation, meaning that students' grades in math were pretty stable. If you know what they got in the spring, you got a pretty good idea. I mean, if you know what math grade they got in the fall, you have a pretty good idea of what they got in the spring. Their grades stayed fairly similar. But we did see a change in the mean, so let's see if that difference is statistically significant. Here, okay. So this number here is the difference between the two means, which we saw was about half a point. And that's the standard deviation of the difference between the means. So in the book, it just gives you a formula for how to calculate the standard deviation of the difference between the means, but it's quite a bit of hand calculation and it's kind of a bear. So It's good that SPSS gives you that. And then the standard error of the mean is basically taking the standard deviation of the difference between the means and dividing it by the square root of the sample size. So it's a measure of the average difference between the difference of the means, comparing samples to populations or the population. This is the confidence interval of the difference between the means. And as you can see, both the lower and the upper values of this confidence interval are both positive, and it does not include 0. So it looks like there is a difference between these two sample means in the population. Remember, a confidence interval says, using sample data, what would we predict the population parameter to be within a certain interval? And this tells us we're 95% confident that the actual difference between the population means on this variable, math grade, is positive between about 0.40 and about 0.71. So we expect that there's a difference between the population means on math grades. If we calculate the t-test, which would be taking this difference between the means and dividing by the standard error, we get this t-value, 6.950. We get 839 degrees of freedom. That is the number of pairs, which was 840 minus 1. That's the degrees of freedom for a paired t-test. And the sig two-tailed, that is our p-value. And this p-value is 0.000. And that tells us the probability of getting a difference between the sample means on math grade this large or larger by chance is less than 0.001, meaning highly statistically significant. That p-value, I just wanted to show you, if we look up this t-value with this many degrees of freedom in Appendix B of Statistics in Plain English, you'll see we can't get, this is our degrees of freedom. This is our Appendix B. Degrees of freedom is over here. And we've got a big sample with a lot of degrees of freedom, 839 degrees of freedom. So we'd have to use this infinity row here. And remember, our t-value was over 6.00, and the largest critical t-value that we get in this appendix for this degrees of freedom is 3.291. And that, the probability of getting that t-value, 3.291, by chance is 0.001. So the probability of getting our t-value of 6.950 by chance is even less than 0.001, which makes sense. So we've got a highly statistically significant difference. It appears that in the population, math grades are lower at the end of the spring quarter than they were at the end of the fall quarter for high school students. We don't know what population this sample of high school students represents. You would need to know more about this sample to make that determination. But whatever population this sample represents, it appears that there's a significant difference in their fall and spring math grades. So that's how you conduct paired samples or dependent samples t-test in SPSS, and that's how you interpret the output. I hope that's helpful.